all, my name is Mishra. I am a committer in Jumbune. Today we are going to demonstrate the Flow Debugger, which is also known as a flow analyzer component of Jumbune. This component is primarily meant for MapReduce developers. So typically the case is that there are data science team, right, which models the whole analytical programs in some statistical languages, and then the developers typically adopt those programs, those models, those algorithms into the typical MapReduce applications, which eventually executes on the clusters. Right now, what usually happens is that when a MapReduce developer is trying to adopt the statistical algorithm onto the MapReduce language framework, right? So it's like, written in some of the languages. It's like, could be in the Python, it could be in the Java, it could be on the .NET or any other programming languages, right? So this component supports the Java implementations of the MapReduce. So what happens is whenever a developer is going to implement some logic, right? So they are going to first test it on their own local development environments, on their own local community systems. Right after that, the solutions what they have implemented is going to get ported onto the QA environment and eventually to the whole cluster, right? Which is more or less kind of a staging, and then eventually to the production. Now, as you typically write down a MapReduce program, right? So you typically write the mappers and reducers. You've got a small subset of data on which you run the program locally just to verify that whatever the analytical output your program is expected, is it getting the same analytical output or not. So typically what we do is like, we do implement that and we run it with a small, say, megabytes or gigabytes of data which is lying on my local box, which could be a subset of the eventual whole cluster's data, right? And then we eventually run that onto a local box. The program runs very well on my local box, but then when the same program or same analytical logic or the same MapReduce based solution of Hadoop, right, gets ported onto some production environment, right? So there, or in a staging environment or on the QA subset of data, right, we typically don't get the same analytical outputs, right, what we were expecting, right? So then comes things back onto the developers that what's the cause, right? What's the cause of the primary or the root cause of the failure? Why we are not getting the exact kind of the analytical outputs, right, what we were expected. So then the developer comes back on his on his machine, right, tries with, right, delves into the code and figures out basically what's the root cause of, like, discrepancies in the analytical reports, and then eventually again submits the solution back onto the cluster or on the QA environment just to re-verify that whatever the changes has happened, right, are they reflecting the correct analytical reports right now or not. So this is like typical to and fro which happens on the development machine to the QA environment to the staging to the production environment. So we are going to demonstrate, right, how we are going to demonstrate you that how Jumbune can facilitate you so as to reduce the time of efforts and do-throughs, right, which happens between these environments during a life cycle of a MapReduce solution, and how it can bring down or how it can tear down the efforts or the the amount of time which has been spent, right, by the developers, by the QA folks, right, on the solution, from say hours or days of efforts to eventually to the few minutes, right? So we are going to demonstrate that. It's a quite unique feature, up to best of our knowledge, right? None of the solutions, right, or none of the Hadoop-based solution enablers are having this kind of feature. So this is truly helpful to the MapReduce developers by and QA too. So we are going to demonstrate it. So right now you can see, right, we are on the home page of Jumbune. So we have got a couple of options, right, so as to operate Jumbune. Jumbune works on the YAML, right? YAML is kind of an a property, text-based property format, right? So Jumbune takes the instructions in the format of YAML. So we have got a couple of options, right? You can see there's a new, right? You can create a new if in case you don't have any YAML wizard which is existing. You can create altogether new. You can open an existing wizard, right, if in case you are having one. or you can select one if in case you already submitted one previously. So it's kind of an historical jobs, right? Kind of that. Just so what we did was like we selected the select, and then it shows us like in the historical jobs, right, which was submitted previously. So you can see, right, when we select the YAML wizard, it opens up the whole YAML wizard for that particular job submission. So this is like kind of an instruction to Jumbune that so you do this thing on Hadoop cluster and let me know these things. So it's like more or less like an instruction wizard, right, just to facilitate the users. What we have got is like first tab is like basic tab, right? We won't go through it right now so deeply, right? There are enough documentations on the website which can assist you so as to go and like understand, right, the physical significance of each of the fields which are there on the wizards. I will quickly walk you through this. So this is basic, right? It takes care of like all the basic Hadoop cluster information, what are the masters and slaves and which ports are there. The second talks about like the MapReduce job. This is the actual job, right, which you would like to debug, right? So this is the actual job which was concerned, right? So the developers did something and like that went to the staging environment or queue environment, failed to get the right analytical results, again came back, the developer again saw something and like again submitted it back. So this is the concerned job, right? This is the tab. So you can see, right, what we are doing here is like this is the file path of the concerned job, right, which we want to debug or flow analyze this thing. So we take a couple of things here, right? The number of jobs, basically name of the jobs, parameters and whatnot. These are all regarding that job. We go on to the next tab. All the tabs from here are like optional tabs. So you can see the next tab is like flow debugger. So this instructs the Jumbune that you require to enable the flow debugger or you require to enable the flow analyzer. So typically in a development environment, right, I would be able to debug my local box, right? So whatever the data which is there on my local box, I require to debug that, right? But what about the whole cluster, right? If in case I've got a whole 20 node or 100 node clusters and my MapReduce instances data is all distributed across it and my MapReduce instances are running all across this 20 to 100 nodes, right? So now how I'm going to look at each of the node, that what exactly happened during the execution on the node number 21, what happened to the execution on node number say 79, what happened when your MapReduce job was executing on node number say 65. So no way I would be able to look at it, right? Even the degree of parallelism increases because it's not only about like all distributed programming, it's also about the parallel programming. So due to the advent of like the multiple cores or the hyper-threaded CPUs, right, we can run multiple instances or multiple tasks at a single time at the same time. So on node number 65, right, there could be 4 mappers or 3 mappers which are running at the same time. So you multiply all of them, the given job, and then multiply with the number of mappers and reducers. Then you multiply the number of nodes which are there. Then you multiply it with the number of parallel instances which are running, right, on the job. And then this is the degree of parallelism. And then you are trying to debug it. It's like nearly invisible, or I won't say it impossible. It's nearly invisible so as to debug it, right? So this here, what we are doing is like we are enabling you so as to debug or analyze, right? What happened to the flow at that degree of parallelism. So what we are doing here is like we are enabling the debugger, flow debugger. Then we are saying that yes, I've got few regex, right? So if in case I can express my validations, right, using an regex expression, you can specify that yes, I want to use an regex. So how it works is like you can specify the regex at the mapper level and the reducer level. So you name your mapper or reducer on which you would like to apply the regex. So this is a regex which is going on to the output of that mapper or reducer. Then you specify your regex. So obviously there are like keys and values, right, which goes out from the mappers and reducers, right? So what we have enabled you is like you can specify the regex on key also, you can specify regex on your values also. So what we have done here is like we are specifying the regex on key, we are specifying a regex on the value, right? If in case the regex does not enables you to express your say, how should I put it, right? It's like, enables you to express the violations or the verification code. We do provide you the interfaces, right? You can implement those interfaces so as to write down your custom proprietary logic of validating the mappers and reducers, and eventually to the keys and values, right, which are coming out through the context of those mappers and reducers. So in this example you can see, right, we have provided one regex, right? Also what we have provided is like, kind of a user validation. So one regex basically, this is a mapper or reducer. You can specify that yes, on this mapper or reducer I would like to put an user validation. This is my class implementation, right? So you can always implement that custom plugin interface, and you can provide your own implementation of the validation class on the mapper and on the key and the value. So these are like, the custom written code, right? So you can always write down your proprietary custom code there. And then we can, since this is the module, right, we are talking about, so we are going to just say finish, and eventually if in case that gets validated, yes, this has got validated successfully, we can run it. So this is the output of the job, right, what we submitted. So as we can see, there is only one tab, right, Flow Debugger, which came for the request, right, what we have given to the Jumbune as a YAML wizard. You can see, we are going to explain out this report, right. This helps you to understand, right, how your execution flow happened on the whole cluster. It's not only a single node, it's like, whole cluster's execution flow report of your MapReduce job. Your whole job, right, this is the concerned job, right, what we were talking about, right, or like, which we wanted to debug it, or execution of that job, what we wanted to analyze, right sense. You can see, right, some small tabs here, right, one is for the J, which symbolizes the job, then there's an M, second one, which symbolizes the mapper and reducer, and R is not written, and then there is an I, right, which is the instance or the task level information, right now there is a J, which is first one, which in case we select, this gives you the whole information about the job. You can see the input keys, output keys, unmeshed keys and unmeshed values. These two are self-explanatories, the input keys and output records, but the unmeshed keys and unmeshed values I would like to take a minute so as to explain it to you guys. Unmeshed keys and unmeshed values are the ones, right, which we got in response to the regex and the user validation classes what we have submitted during our job submission. So whatever the validations what we have put, right, on the regex, on the user validations, they got verified, and eventually this is the output of those validations. So a very simple analogy understanding what we can have is like, out of this 37,206 output records, right, which went out of this job, there were like 7,454 keys, right, which were unexpected, and then there were like 6 values which were unexpected, right. So I can very well see, right, that yeah, my job is producing an unexpected output. The amount of unexpected output, we can see that 7,454 out of this, and 6 values out of this, right, were unexpected. So we require to delve into it, right, because still we haven't found, right, where yes, we got that this was the degree of unexpectedness, right, from our job, right, but then, right, we have not yet hit the root cause, right, what happened, right, what exactly has happened, right, where I require to fix the code, what was the problem, right, we are gradually delving into it. We can see there is a chain which is written out here, right, this is all about, right, MapReduce chaining. So yes, this do support the MapReduce chaining also. So if in case you got multiple mappers and then reducers and then eventually mapper and MapReduce chain which is going on, so this can sort you and give you more information about that also. This also do support, right, kind of a job chaining, right. We go into the second level, which is the map level. So we can click here on the M. We get to know the information about the mappers and reducers in that job. So yes, there were like 4 mappers and 1 reducers which were there in that job. right? The whole output keys, right? We can see there, like what were the contributions of the individual mappers and reducers. You can see the unmatched keys and unmatched values. So there was only one mapper, right, which contributed into the unmatched keys, and there was another mapper, right, which was the US region. No, sorry, this is the third one, which is a reducer, which eventually contributed into the number of unmatched 6 number of unmatched values, right? So still this has given us a fair insight about the mappers and reducers which eventually contributed. So we can see from this report that yes, there were 1, 2 and 3 tuple, then the second one, which is the region mapper, and the third one, which is the US region mapper, they have not contributed into any violations, right? So there are only 2 culprits now. The third one, which is port out reducer, and the last one, which is service provider mapper, right? These are the 2 culprits, right? So the whole job, right, we verified, we went into the mappers and reducers level. Now we require to get more information about it, right? So as you go into the instance level, you require to select one of those. Say if in case we are taking the third one, which is port out reducer. In case you go to instance level, yes, there were 2 instances which ran on the cluster, right? Only 2 instances which ran on the clusters, and you can see, right, what were the contributions of those individual instances or tasks onto the unmatched values. So the first instance, basically, which is listed here, has contributed 2 violations of the values, and the second one contributed 4 violations of the values. We go into the service provider mapper, right? If in case we can see again, right, the number of this is a mapper, right? So these instances are mapper instances. So you can see the contributions of them, right? What were the contributions of these instances onto the cluster. It can happen that based on the data or based on the locality of the data, there could be case that you can see a heterogeneous contributions of the mapper instances or tasks onto the eventual total contributions, right? So we got into this. Now what we are going to do is we are going to go into the exact code level. So if in case I click on this one of the instances, we can see more detailed information about them here, right? So this is here we are going into the code level. There is also a color criteria, right? There's some different colors, kind of a red and kind of an indigo color, right? What we can see. So these are just to differentiate the nodes, right, on which these mapper instances have run. So you can see that also. So if in case you are trying to match the data violations, data locality with the data, with the nodes, right, this can assist you that yes, this node contributed, the code logic is exactly same, but it could be the reason that there's a data violations or data discrepancies, right, which are affecting into the code violations, right, or the code validations. And then there's another module in the Jumbune, right, which is the data validator. So even you can go through it, right, just to sanitize your data, and which can help you out to figure out, right, that where lies the data validations. That's a different thing, right, and we won't talk about that in this presentation. So as we delve into it, right, we can see the mapper. We went into the instance level. We can see here, right, this is talking about the code level, right. You can see in a map method there are different methods. Like methods could be, right, a UDF call. There could be a custom method which can be invoked, and sorry, and then there are counters, right. Counters are individual if blocks, if else blocks, if else if blocks, switch case statements, and different statements, right, which are there, right. So you can get all information about that. So as you go into it, right, we can see that yes, there were mappers on that. Basically this method was called, and then there was some counter. What we require to see is we require to see some unmatched values, unmatched keys here, right. So you can see here that there's an if block, right, which has contributed onto the for this 3726 keys. If in case we start from hovering from the top, right, first one, this has not resulted into anything. If in case second, third, fourth, I guess this is like fourth, right? Yes. So if in case we click here, right? Yes. This has resulted into 3726, and we can see it here also. This gives an if block number 1, and this is line number 35, right? So which is like there is an if block. So if in case I go back, right, from down to up, right, we can figure out the root cause. So there is like in your job there is a service provider mapper class, right? Inside that class, right, we can see that in the map method, right, on the line number 35 there is an if statement which is resulting into unexpected data, right? So what we can do is like we can go back into your code, right? Go back into your favorite IDE and then open the code and then can verify the statement, right? Whether and that's like kind of the root cause of the unexpected behavior. Apart from that, this is like whole table view. We also give you a chart view, so you can click on top, right? We should be able to get the whole chart view, right, which just summarizes the whole details in another way. So that also we can see. This, I guess this summarizes more or less about the flow debugger or flow analyzer. This is just to sum it up, right? This is like whole cluster wide flow analyzer, execution flow analyzer, which enables you to see the whole flow on your MapReduce job on the whole cluster. If in case you got any queries, concerns, feedback, suggestions, right, please contact us on users@collaborate.jumbune.org or visit the jumbune.org site. This is an open source initiative, right? Feel free to collaborate with us, right? We will be more than happy, and we welcome you also to contribute to us, to the project, right, and to the developers community, to this open source community. Thank you.